Hello all. Today we are going to see the experiment number 2. The title of the experiment is write an 8664-bit ALP language program to accept a string and display its length. So in this we have to accept the string from the user itself, and we have to store that string, and we have to display the length of the string which is entered by the user itself. So coming to the point, we will directly see the experiment of this particular program is coming to the program. So here again, like in first program, we have initializing the micro which is already explained all about this. So move rx comma %1 which for system call numbers. Move rdi comma %2 for the file descriptor. Move rsi comma %3 for the message which we are going to display on the user screen, and rdx comma %4 for the length of the processors array. Then here the data section, in this data section we are going to display these 7 messages. So whatever the message we have to display on the user screen, that we have to initialize into the data section. For example, here the message 1, which is of size defined byte. So then the string, what we have to display the message, that will be in the double quote. So enter string, and the size of that message will be 10. So which will be entered by the user. That message will be stored onto the L1 variables are there. Then message 2 entered, message 3 length is, message 4 the right title of the experiment, which is write an 8664 ALP to accept string and to display its length is there. Message 5 is existing now, and the message 6 I am displaying here my name. So you can display, you can make a changes according to your specification. So that will be displayed here only. Message 7, section.pss, here the define definitions of all the operations that we are required, that will be defined here. The string, uh, respectively bytes of which is defined of the size 50, that will be stored onto the str1 variables is there, which is declared over here. Str1 variable is declared over here. Count we are defining as a 1, right? And the output we are observing this variable with the with the size of 20 is there. Then the text section is starting. So global start is the initialization process is there. So here messages, first 3 messages will be displayed on the user screen. Message number 6, message number 4, and message number 1 will be there from the input and output declarations are there. So here is the input process. So message input, whatever the is there, that will be stored onto the string will be there. So that's why the input output function, the string will be initialized, and the count will be initialized over here for the input to the microprocessors are there. Now output process. The output process is defined over here. The message 2, message 3 will be displayed on the user screen to display the value of the count of the pass into Rx register. So that's why we are defining over here move Rx comma count, the address of the count. Then the call hex to decimal procedure over here. The number which we are, whatever the count is there, that will be into hex number is there. So to convert that hex number to decimal number, this process has been initialized. So this is the process for the hex to decimal over here. So in this we are going to save that particular number into move rsi comma output plus 15, move rcx comma 2. So XOR is the operations between RDX comma RDX is there. So XOR operation that we are already knowing. So 0 0 for answer will be 0. Sorry, 0 0 answer will be 0. one zero one answer will be one, one zero answer will be one, and one one answer will be one is there for the XOR operation. So move RBX comma 10. So in this, the value of a 10 will be stored onto a RBX register. So here these are the 64-bit numbers, registers are there. So that's why it is RDX register. For 8-bit general purpose register, which is AX, of having 0 to 7 bit. For AL register, accumulator registers are there, and 8 to 15s are for the AH registers are there. Then 16 to 16 plus 32. So 32-bit registers will be defined into a EAX, EBX, ECX, and EDX registers are there. Again, combining these 32-bit two registers of AX registers, so it will be becoming 64 register, and which will be defined into a RAX, RBX, RCX, and RDX registers are there. Now here we are use compare instructions. So compare DL with 09. So the division, since the division of the remainder said to be a data byte, so that's why this comparison has been done. If the result of between the DL register and the 09 register, which will be greater, for the comparison there will be three outputs will be there. First is greater than, second is equal to, and less than is there. So DL will contain the result between the greater number from DL to 09H is there. Now if this number is below, then the add 33 add 30 values, right? So if this number will be below, then the 09, then the ASCII values of that particular number from that, because the hex numbers are lies between 0 to 9 and 8 to F is there. So if the number is less than 9, so it will be as it is defined, store onto the arrays over there. So then this procedure will be used. Now if the number is greater than uh, 30, 09H is there, 30 is there, that it will be continue on to the next process is there. So this will be the program. Now we will run this program. Now here for the string input I will give MMIT college. Now I am running this. So enter string will be MMIT college, and the length of the string will be 13 is there. So it is the output of the program. Thank you all.